All right, last example. So here, another set of polynomials. This one, just the factor may be a little more difficult because we have some complex quadratics here, no GCF in any of these. So here we are going to factor like this. We're going to multiply 2 times 15, and we get 30. So we want numbers we can multiply to get 30 that we can subtract to get 7, right? So that's 3 and 10. So then we want this to be the sign of the bigger number. This tells us our signs are different, so the other one will be negative. And then remember, what we want to do is we want to divide by the value, the a value, right? The value in front of the squared variable. So 3 over 2 doesn't simplify, so that 2 just comes over. But 10 over 2 simplifies to 5 over 1, right? So we could put the 1 in here if we want, but we don't need to. We can just keep it invisible. So we end up with 2p minus 3, and then p plus 5. Okay, so that's what this one factors to. All right, so this one's similar situation. P here, P here. We're going to multiply 2 times 12, which is 24. And we want numbers we can multiply to get 24 that we can add to get 11, right? So that's 8 and 3, or 3 and 8. So we put those in. This is the sign of the bigger number. So 8's going to be negative. And then this positive tells us the signs are going to be the same. So they're both going to be negative. And then we take the a value and put it underneath. Okay. Similar, that 3 over 2 doesn't simplify, so that 2 is going to go to the front. 8 over 2 simplifies to 4 over 1. So the 1 can go in the front, but we don't need to do that. And remember, the reduced numerator stays there. So it's going to be p minus 4 and 2p minus 3. Okay. All right, and then last, deal with this one. This is a simple quadratic. So numbers we can multiply to get 20 that we can subtract to get 1. So we put a p here, and those numbers would be 4 and 5. We want to end up with a positive here, so our bigger number is going to be positive. This tells us the signs are different, so there's going to be negative. We don't have to divide by a because this is a simple quadratic, right? There's a 1 in front. So you could put a 1 in the bottom. Same thing either way. All right, so now let's find our LCD. So we'll go shopping. I need one of these, and that takes care of this one, right? So that I have a match. They both have the same exponent, and so it's just going to be 2p minus 3 to the first power, okay? And then we need one of these, which matches up with these. They're both to the first power, so I'm going to need that, p plus 5, okay? And then let's see, we need also one of these, and they match up, and they're both to the first power. So that gives me everything I need, right? It represents this, and it represents this. It represents each of them completely, but not in excess, right? I don't have anything that I don't need. So we're trying to be efficient, go green, save the planet, right? So we don't need any excess. So that's our LCD. So we're not done yet, but that's our LCD. So now I want to get these expressions. So I'm going to start with this one here. I'm going to write the factored out denominator. So I have 2p minus 3, p plus 5. And I want to think about, okay, what should I multiply this by to get it to be this, right? What's missing? And these are pretty obvious. Sometimes easier with polynomials because it's pretty obvious what you're missing. So p minus 4. So I'm going to multiply by p minus 4 on top and bottom. And in this case, you can actually just write it like this if you want. P minus 4, just put it there, and then just put it here. And sometimes it can be that easy, right? So we'll just save that as one of our equivalent expressions. So then the next one is p, and then I'm going to take its factor denominator. So I'm doing this one here. So that's p minus 4 and 2p minus 3. So what's missing? This one, right? Clearly, p plus 5. So I'm going to put p plus 5 here. And then I'll just put a p plus 5 on top. So I'm multiplying the top and the bottom by p plus 5. So that's what it'll look like. And then the last term, or the last rational expression, we have 2 over p minus 4, p plus 5. And this is missing a 2p minus 3, right? So I'm going to multiply by 2p minus 3 on the bottom. I'm going to do the same thing on top. And that's it. All right, so factor the denominators, find the LCD. Once you find the LCD, you're going to multiply whatever component of the LCD that's missing from each denominator to make it into the LCD, right? You want to figure out how can I make this denominator into the least common denominator so that they can all match up, right? Now these denominators all match up. So if I did want to add these together, I could do that. I might have to do some distributive property, right? Maybe some FOIL from time to time. But yeah, that we definitely know how to do.